So we are doing across this R2, and now whatever RL is there, this circuit you can put it back. Okay, so now again I can just join this circuit here, and this is my new circuit. Okay, I can, instead of this one R1 R2, now I have a single resistance R Thevenin, which is R1 R2 upon R1 plus R2, and this open circuit voltage VB in now become my V Thevenin. Okay, and this is my new circuit. Okay, is there an issue? So can I make like this circuit like this? So this is my open circuit. One is ground, other is connected to B. So I have connected to B. Okay, this is my load, become a load, and remaining this one I have my equivalent circuit. Now, but once you understand that redrawing this circuit, now you can do your calculations. Okay, so this is my plus VCC here, which is like this, and now I can do my calculation like earlier. Now everything is same. You have to write for input. Okay, for input loop, become minus V Thevenin. Okay, and here you have IB plus IB into R Thevenin, voltage drop here, plus VB plus VB, and then you have again here IERE, which is equal to beta plus 1 IB RE. So this is beta plus 1 IB RE equals to 0. Now I want to write what? I want to write IB, that is V Thevenin minus VBE, okay, R Thevenin plus beta plus 1 RE, okay, and beta will be given. So you go back to the out, so you can find the IC equal to beta IB, okay, and you can find the IC saturation. For IC saturation, you have to put VC equals to 0. Now you have to understand, this is not always VC equals to 0 for IC saturation. Okay, but if nothing information is given, then only then we take VC equal to 0. Sometime they will give you the value of VC for IC saturation. Like here I put equation when I calculate IC saturation. Basically my equation is what? My equation is VC equals to VCC minus IC RC plus RE. This is my equation. But I will put now if I want to calculate IC saturation. So my IC saturation formula is what? My IC saturation formula is basically VCC minus VCE upon RC plus RE. This is basically IC formula. So IC saturation means VC saturation. Now VC saturation I generally put 0, but sometime in the exam question they will give you the value like 0.2, because I told you the graph na, in this graph what was that? IC was like this, IC equal to VCE. This type of graph was there. So close to anything less than 1 volt or 0.7 volt should give you the saturation. So instead of taking VC 0, sometimes they will value, they will tell the circuit in the saturation, and this time the value is VC this much. That time that you have to use value is this value. Okay, so I am putting it now in this formula like this. If nothing is given, then you put 0. If value is given, then you put whatever value is given, and you can find the IC saturation and compare, and you can find the operation region. Okay, so once you know the IC, you know the VCE, you know the operating point. Okay, so the circuit is solved. So rest thing is same. Let me do one problem. So I'm erasing this one, or you write down. So biasing is completed now. Okay, we'll do 1 or 2 problems and then we'll go to the next topic. So biasing is very simple. DC biasing is simple because you have to do DC biasing before you do AC analysis. And now if the question says the R1 value is 10 kilo ohm, R2 value is 1 kilo ohm, okay, RC value is 2 kilo ohm, RE is 200 ohm, beta is 100, and VBE is given 0.3 volt, VCC is given 10 volt. Solve the circuit for accurate biasing, voltage divider biasing, and tell me the answer. The first thing is you to find the VThevenin. So VThevenin will be equal to what? VThevenin will be equal to VCC 10 volt upon R1 plus R2, that is 11 kilo ohm, into R2 is 1 kilo ohm, cancels out. 10 upon 11, that is 0.9. How much will come? 909 volt. And R Thevenin is R1 R2, that is 10 into 1 upon 11, same thing, 0.909 ohm, kilo ohm. Okay, best thing is value is given. You can put in the formula and you can find what is IB. So what is the formula for IB? IB is basically VThevenin minus VBE. So VThevenin is 0.909 minus 0.3 volt. Then you have RThevenin 0.909 kilo ohm plus beta plus 1 RE. Beta plus 1 means 101. RE is 200 ohm. Okay, so this become 0.9, so 0.609. You can calculation, you can check. Okay, I'm just roughly doing. And now this is 0, this is 101. If I put point here, so this is 202. So this become 2. Tell me how much it become value. Solve this one and tell me what is the value of IB. I have the answer 28.43 microampere. After solving this one, I'm getting 28.43 microampere. Please check and tell me. What is the value?
28.4 micron.
Okay, 28.4 microampere. So IC will be how much? 2.84 milliampere. Check it. How much should come? So if you multiply 284 microampere, 0.28. How much? 284 milliampere. Is that correct? If you multiply 100, what will become? 10 is to power minus 4. You want to multiply by 10, 3 and divide 2.8. It's correct. Okay. So this is, you have IC out. Now you have IC. Now you can find VCE plus you can find, for comparison, you can find the IC saturation. VCC 10 upon RC plus RE. Okay. RC is your 2 kilo ohm plus RE is 200 ohm, 0.2 kilo ohm. That is 100 upon 2.2 kilo ohm. So which is much larger. So it is a 28 or 2.8. Just check it. No one is replying.
28.
28 है. 28 एम्पियर है ना, मिलिया एम्पियर. अरे भाई, इसको 100 से मल्टीप्लाई करेंगे तो क्या हो जाएगा? ये 4 हो जाएगा, ये 4 हो जाएगा. ठीक है. अब इसको मुझे एक 100 डिवाइड करना. 2.8 क्यों नहीं आएगा? ये तो यहाँ पे कितना आ रहा है? 284 आ रहा है क्या? This is 28.4 or 284?
Sir, IB is 28.4.
And then IC? Beta is 100.
2.84 milliamp.
2.84 milliamp. And this is VCC. This is VCC 10. And now check it. This is how much coming. So it should be obviously greater than this one. So this is in the active region. Operation region is active. Check this value. It should be greater than this value. And VC will be what? VC will be VCC minus IC RC plus RE. 10 minus 2.84. RC is 2 kilo ohm, RE is 2.2 kilo ohm, 2.2 is the milliampere, and this is 2.2 kilo ohm. Okay, and this is, if you solve this one, this should come around 3.7 volt. 3.7 volt. So let us now go to the next topic. ये तो हो गया सबका ना. बायसिंग सबको आगे करना. Biasing is very easy. Circuits are very simple. Methods are same. Formula you can remember. If you don't remember, immediately you can write the formula. You can do calculations. How to find the operation region? You can find. Okay, whether it is active, whether it is a saturation, and whether it's a cutoff. Some problem we will do more for saturation and cutoff. Active region problems we have done many. Okay, now cutoff and those problems we'll see later. Now I want to solve. What are the applications of transistors? Okay, some special transistor circuits. Special transistor circuits. So first is Zener follower regulator. Zener follower regulator. Okay. So use of transistor in the regulator circuit. So what is the how can we use the transistor in the regulator circuit? We can use here. We have a resistance here. And then we have a power supply, say here, VCC. This is my base, this is my collector, and this is my ammeter. So NPN, so this is NPN. Okay. Here ammeter, we have a load resistance RL. Here I can put a Zener diode. in the ammeter base loop, Zener diode, and here you can put RC. So basically the same circuit, instead of R2, I'm just putting a Zener diode in the circuit. This is a basic voltage divider circuit, and I'm putting a Zener diode instead of R2. Now what will happen? And this is required voltage VZ if this want to conduct. And here you can put some value R. Now I want to make a fixed regulated voltage. And regulated voltage I can get across here. If I across the RL, if I measure the V0 across this RL, this V0 if I measure across RL, then this should be constant. Okay, that is the meaning of voltage regulator circuit. Now, first of all, you have to check whether this Zener diode is on or off. So just for checking whether Zener is working, it is conducting or it is off, you have to see the open circuit voltage across the Zener. So I will remove this one. I will find what is the voltage here. If this voltage is greater than VZ, then Zener is on. Otherwise it is off. Otherwise you can make it open. So now, first thing, measure open circuit voltage across Zener diode terminals. Okay, if it is conducting means we open across Zener diode is greater than equal to VZ. Okay, we open across Zener diode is greater than equal to VZ, then I can replace this by a battery. Then I can replace Zener diode by battery of VZ. Now you have a loop completed. So now what I can write minus VZ in this loop KVL, minus VZ plus VB. This is VBE plus VB plus V0 equals to 0. So V0 will become generally what? VZ minus VBE. Now this is the constant voltage. Once Zener is on, this output becomes constant always. यहाँ पे क्या change हो रहा है? That doesn't matter. This V0 RL is changing, doesn't matter. Okay, automatically this V0 become fixed here as soon as this is on. And now generally VZ is very high. This is 0.7 or 0.3. VZ is generally very high compared to VBE. So we say V0 is almost equal to Zener voltage. This is the voltage regulator circuit. This is your voltage regulator circuit. Okay, so this is your C, this is your B, and this is your ammeter terminal. Now let us find some problem, solve some problem based on this circuit. Is that clear to everyone? Amardeep,
Yes, sir.
clear enough?
Yes, sir.
Okay. Now this is my C, this is my B, and this is my E. Okay. Now I will just tilt the circuit. Either circuit will be drawn like this. Sometimes the circuit comes little bit. You rotate the circuit fully. Okay. So let us see one problem which also came in exam. So you have this is here, your E terminal is going here, your C terminal is coming here, your B terminal is here. Okay, and B terminal was what? B terminal. Now you have to at B terminal, what was there? Zener diode was there. Zener diode was there. Basically, here you have voltage divider circuit. Okay, so voltage divider circuit means you want here one more R. Either you connect here, that is same thing. Either you connect here or here, that is the same thing. So this is your base, and here you have a VCC. Now I'm telling this is a V input, and this is the resistance R. This is V. This is called VZ, and here I am measuring the RL, and here I'm taking the V naught. Now the value of R is given 680. This is 680 ohm, and V input is given 20 volt. This is VCC is given 20 volt. VZ is 10 volt. VZ is 10 volt, and RL is given 15 ohm. Okay, the value of RL is given 15. Let me check. Load is 15 ohm. 15 ohm. Beta is 80. VBE is 0.7 volt. Okay, so you have to find out V naught. Okay, a current I load, current IE, I ammeter, I base, I collector, VCE. Whatever things you can find, you have to calculate. All of these things you have to calculate. Now, what is the first job? What is the first job? What you have to find first thing?
Open circuit voltage across Zener
Yeah,
diode.
Zener diode. Okay. First, you have to check whether Zener is on or not. And if it is on, then things become very simple. You can directly calculate everything. So for the moment, and you have to also calculate the Zener current, IZ. So for the moment, first I'm checking. This is not a part of solution. This is just for checking. I'm saying this is off. This is a open circuit. Now, if you open circuit, voltage current will come here. You can directly go to here. Okay, and you can find what is the value. What is the value of this one voltage? Okay, so obviously now this current will become IB because this current is going here. This will be IB. This will be IB only. IC is going here, and IE is coming here, and IE is only falling, making I load. So first of all, let us find what is the voltage across this one, and what is the voltage of VB. So we have to find basically what is VB, which is VZ. So solve. So now you have to find first value of IB. What is the value of IB? So IB means minus 20 plus IB into 680 ohm. Okay, I'm coming here. Then I'm going base to ammeter. Here is a VBE plus VBE 0.7. I'm writing directly. And then we have here IE is equal to IL, which is beta plus 1 IB into 15 ohm. Into 15 ohm. Beta is 80. Beta is 80, and then this is the 15. This is equal to 0. Now tell me what is IB. So IB will become 20 minus 0.7, 680 plus 15 into 81 RE, IB, RE, RL also. 15 ohm can na? 15 into 18, 81. Tell me the value. What is the value of IB? And what is the voltage drop across R? This is 13.19.3. Solve this one and tell me the value in microamperes.
10.1 micron.
How much?
10.1.
Please, someone also others also check one. So what is the voltage drop here? So if I assume this one, so voltage drop across R is 10.1 microampere into 680. So this become how much? 10 to the power minus how much volt?
It is milliampere.
This is milliampere, huh?
Yes, sir, milliampere.
milliampere. तो कितना आ रहा है ये? 6.8 वोल्ट कितना आएगा? This is 0.60 current. This divided by this one 0.68 multiplied by 6 around 6.8 volt. I'm writing around roughly 6.8 6.9 volt. Is that correct? Six eighty into 10.1. How much?
6.8.
Okay. So the idea is this is 26.8 gone. How much remaining here? Around 13. Suppose this is 7 volt. So 7 lost here. So this is coming 13. This means zener is on. Okay. So open circuit voltage across VZ. So open circuit voltage across Zener diode is greater than, this is 13 volt coming 13 volt. I'm roughly writing which is greater than 10 volt. That means Zener diode is on. So this is first part is just for checking. So now we know this is working. Now our calculation will change and things will become very simple. Now I can find everything very simple manner. Now I know this is my 10 volt. This is on. And now this circuit is very simple. I can find my V naught. So I can write -10. This minus 10 plus VB 0.7 and plus V naught equals to 0. V naught become 10 minus 0.7. That is 9.3 volt. And once I know the V naught or VL, V load, I can find my IL, which is equal to I ammeter. I know now I ammeter, which is 9.3 this volt divided by 15, which will come out 0.62 ampere. Okay, or 620 milliampere. 620 milliampere. Please साथ में कैलकुलेशन भी चेक करते जाना. Now you know you want to find IL, IE. Now you want to find IB and IC. Okay. So IC and IB both are same. Little bit change. So you can find now IB. IB, how can you find? So I can consider IE, okay, is almost equal to IC. Some difference will be there of IB. Or you can write IE is equal to beta plus 1 IB. So you can find the value of IB. That will be IE upon beta plus 1. That is 620 milliampere divided by 81. How much coming IB?
7.65.
7.65 milliampere. And now you can find the IC value. IC value will be IE minus IB, almost same only. This is 7.6 milliampere. This is 620 milliampere. 620 minus 7.6 milliampere. So how much will remain? 612.35 milliampere. So you know IL, you know IE, IB, IC. Now you want to find what is VCE, VCE and IZ. Okay. So that, and you can also find the current in the resistance IR. So VCE will be how much? VCE is basically VC minus VE. And VC is already given 20 volt directly. And VE, we know how much we load. How much we load? 9.3.
9.3.
9.3. 9.3. So this become how much? 11.7 volt VCE. Now you can find the current I, how much this is I, and how IB already you know. And I now you can want to find IZ. So first you need this current I, then only you can divide IB and IZ. Because the diode is conducting, so there should be some current IZ. So first you have to find IR. So IR, this is 20 volt. So I will be what? This 20 and this is 10 volt. This is 10 volt. So 10. So 20 minus 10 upon 680. This is your IE, and IB already you know. So this is 10 upon 680. How much is coming? IE 14.7 milliampere. This is your IE. And now if I want IZ, IZ will be I minus IB. I is 14.6 milliampere minus IB is 6.75 milliampere. You can calculate how much is coming. Almost 7 milliampere. $6.95 milliampere, na? 6.95. 95 or 7.05? How much? 7.05
7.05.
7.05.
milliampere. So everything is solved. So that question is nothing. Question is very simple. Only you have to find whether VZ is on or not. If once it's on, then this calculation is very easy. You can find this V naught immediately. Once you know immediate, you know the ammeter current, beta will be given, you know the IC. Okay, you know the IC, you know the IB. And then once you know the IB, you can calculate the what is the IR here, and then you know IE, you can minus IB, you can find the IZ. VCE, you can directly calculate. So this is become very simple. Okay. The only thing is that you have to first you should know that it's working as a regulator. So it should work as a regulator, then remaining is very simple. So I'm giving you one more question. You can do it. This is by making R Thevenin also. Okay, you can remove this diode and you can make R Thevenin, and then you can find out whether it is working or not working. That is also one way. Okay. So this is your. Once you learn the electronics, you try to with your own method. This is 12 volt. This is C. This is E. This is V. You have to find the VC. Okay. So 220, 1 kilo ohm, 20 volt. Okay. BZ is 12 volt. Everything is given. And now you have to find all the things. Beta is 500. Beta is 500. Given. Okay. You have to find now V naught, IC, V naught, IE, IC, IB, IR, IZ, VC. V naught I'm using here. The first thing is you have to find out whether Zener diode is on or off. And once it is on, you have to tell me the values. If it is not on, then this becomes simple circuit, this becomes removed, and then this becomes simple circuit of transistor ammeter bias. It's on, Zener is on or off? Open circuit, find the open circuit voltage. So first remove this one and solve how much is IB is coming. Okay. So IB value will be how much? IB value will be, tell me, 20 minus VB is 0.7. You can take 0.7, 220 plus, this is beta plus 1, 501 kilo ohm. And this is 220 ohm or kilo ohm, only given. Okay. So we can almost neglect this. This is nothing, 0.2 kilo ohm. So that is nothing. So you tell me how much is coming IB, solve the IB and find a drop across this 220 ohm. This will be in microampere. Okay. So this will be how much? This is 19.3 and this is how much? 501 kilo ohm. So 500 onto 1.2 kilo ohm. This will be how much microampere? Tell me. Around 38, 39 microampere.
38.5.
Huh?
38.5.
30.5 microampere. Okay. Just check it for calculation properly. This 500. Okay. 500. This is 10 to the power 4 and 100 1 microampere. This become microampere. Sorry. This 4 go here. Anyone else? Tell me the values.
38.5.
Is correct?
Yes, sir.
Okay. Now you know you can find the voltage. This voltage across here. B open. VR. So VR will be 220 into 38.5 microampere. You can do roughly because you are roughly only. How much coming?
0.084
Point
084.
0.084 volt. Okay, so this loss is nothing. That means this is, so this Zener diode is on. So forget everything. This Zener diode is on of 12 volt, and now remove this calculation and now solve it. So this is basically nothing loss is there. Everything is coming here. This voltage directly coming here. If this calculation correct. So now you can find minus 12 plus BB 0.7 plus V naught equals to 0. So V naught equals to will be 11.3 volt. Now this point is 12. This point 20. You can find the I. I will be how much? I will be 20 minus 12 upon 220. 8 upon 220. That is 36.4 milliampere. You can check the calculation.
सर ये V नॉट वाला इक्वेशन कैसे लिख रहे हैं एक बार फिर से?
ये यहाँ से ये लूप है ना पूरा.
ओके सर.
ये माइनस वी जेड प्लस वी बी प्लस वी नॉट. यहाँ पे लिख दो माइनस वी जेड प्लस 0 प्लस वी बी plus V naught equals to 0. And from here I'm coming here. And once you know the V naught 11.3, you know the IE or IEL, both are same. IE, IL 11.3 divided by RL is 1 kilo ohm. That is 11.3 milliamps. IB will be 11 point, I will be IE plus beta plus 1, 11.3 milliampere divided by 501. How much is coming?
0.022.
0.022 milliamps.
Yes sir.
220 microampere, na? Okay. Okay. Around 220 microampere. Now, roughly is 220 microampere.
सर इस IB को हम IC is equals to बीटा IB वाले से भी लिख सकते हैं ना?
हाँ तो आईसी तुमको पता नहीं ना अभी. आईसी पता नहीं ना, आई पता है ना. हाँ वैसे भी कर सकते हो. तो आप लिख सकते हो आई इज ऑलमोस्ट इक्वल टू आई सी. देन यू कैन जस्ट डिवाइड बाय बीटा. दैट आल्सो करेक्ट. ऑल रफली यही आएगा. बट अगर सेपरेट सेपरेट वैल्यू चाहिए आपको, यहाँ पर थोड़ा और एक्यूरेट चाहिए, मोर एक्यूरेट, देन यू टू यूज दिस फॉर्मूला. नाउ यू नो द आई बी, यू नो द आई, यू कैन फाइंड द आई जेड. So IZ will be I minus IB. Okay, so I is your 36.4 milliampere. milliamps है ना, milliamp. और ये है 0.022 milliamp. 0.022 है. So 22 microampere है. 0.0 है तो कुछ जीरो से कोई फर्क आएगा नहीं. 36 point, tell me how much. ये 0.2 है कि 0.022 है. Okay, whatever. You can calculate around 32.6 milliamps. 0.2 है कि 0.022 है.
0.022.
0.022 ठीक है. तो ये 22 माइक्रो एम्पियर हो गया ना. So you can subtract this one and tell me what is the value. तब तो ये आएगा नहीं, तब तो 36.4 ही आएगा. 40 डिवाइड बाय 0.02 38 आएगा. और क्या almost 38 or 37.
Yes, sir.
और VC कितना आएगा? VC you can find, BC V0 minus VZ 20 minus BC minus VE. V था आपका कितना? 11.3, तो 9.7 वोल्ट. IC you can find into this multiply by 500. Okay, IC is your beta IB. So everything is solved. Now the next topic is, I'm erasing this one. Calculation, you can do it. I told you the method. Next is your Darlington pair. Darlington pair means now it is a pair of two transistors which always are connected, which come in a packaging. This pair comes in packaging. Okay, always together. So the purpose of this one, increasing the ammeter current. So this is, say this is my one transistor. Okay, and I'm applying here plus VCC, and this current, now I have one more transistor which is connected like this, and this is connected here, and this is going here, ground. Okay, so this transistor has a gain beta 1, this transistor has a current gain beta 2, and say here a current is coming IB1. Say this is transistor T1, this is transistor is T2. Both are almost identical. Okay, so their beta may be same, their beta may be different. Generally beta is given same, so we say this is identical transistor, but otherwise beta may be different also. Now what is the advantage when the transistors are connected in pair? So we know that this is the first transistor current is IB1. Okay, now it has a beta 1, so this current is IE1. Now this IE1 will become IB2 for this transistor, and you get IE2 for this transistor. Now if I want to write IE1, that will be beta plus 1 IB1. This will be the beta plus 1 IB1. For first transistor, because the gain is beta 1. Now this IE1 is equal to IB2. Okay, so the IE2 will be what? IE2 will be beta 2 plus 1 IB2, and IB2 is equal to IE1. So now this become beta 1 plus 1 beta 2 plus 1 into IB1. So now my equation for IE2 ammeter current become beta plus 1 beta 2 plus 1, IB1. Sometime we write it as a beta 1, beta 2, IB1 if they are all very high compared to 1. So roughly we can write like this also, I2, or you use more accurately this formula. Now this transistor, since this is always in the pair, okay, so this is called Darlington pair. So ammeter, so base current, so ammeter current of beta 1 times T1, ammeter current of T1 becomes the base current of T2, such a way that Darlington pair total gain increases, and this gain becomes beta equals to beta 2. Now let us see one problem based on this pair. Nothing, this is only just two, one instead of one there will be two, nothing special. Okay, now let me design one circuit based on this. I'm erasing this one. Okay, so say I have a circuit say VCC is 15 volt. Okay, say VCC is 15 volt, and here I have a voltage divider circuit. So here you have a 10 kilo ohm and 20 kilo ohm, 10 kilo ohm and 20 kilo ohm, and here you have a 60 ohm resistance. Okay, this is connected directly to here. Now it says find the value of find IB1, IB2, IE1 and IE2. Beta 1, beta 2 both are 100. Beta 1, beta 2 both are 100. Okay. Solve this problem. How you will solve? First, either you can use the approximation method. You can say this current is almost negligible, so you can find the VB. So once you find the VB, okay, then you find this VB and this is VB. Remaining voltage will come here. You can directly find IE2. And once you find the IE2, are you getting my point? Either you say this current is negligible first, all the voltage getting drop here and here. So this voltage, VB, now this VB will drop here and here. So VB minus 0.7, 0.7, 1.4, remaining voltage will come here. Now you know the voltage here, you know the resistance here, you can find IE2. Now once you know the IE2, you can find what is IB2. Once you know the IB2, that is IE1, you can find the IB1. Either you do this way, or either what you do, you make an equivalent circuit of this one. So this will come V Thevenin, R Thevenin, and then you have transistor like this connected, okay, connected to VCC, and this is your 60 ohm. What is the value of VThevenin? Tell me. So VThevenin will be same
10
like
volts.
VB. कितना आएगा? VCC 15 upon 30 किलो ओम into 20 kilo ohm. So this is 15.2. 10 volt is coming. Tell me. Check your
Yes, sir.
calculation. 10 volt. और R थेवेनिन कितना आएगा? R1 into R2. 10, 20 upon 30. 20 upon 3. That is 6.66 kilo ohm. Is that correct? You can check it.
Yes, sir.
So this has become 6.666 kilo ohm. And now you can write the equation for IB. This is IE1. This is IE2. Now you write the equation. You go from here to here to here. This is VB1, VB2. And VB and values you can take 0.7. Solve and tell me what is IB1, IB2, IE1, IE2. So you people will be available tomorrow morning? Because tomorrow evening I may not take class. I'm going out station. So if you don't want, you want me to continue tomorrow also, so I can take in the morning class. Okay. So if you are ready, otherwise tomorrow there will be no class of electronics. Tell me, will you come morning, or should we keep leave for electronics? Okay, inform to Satish, because tomorrow evening I will not be available.
Sir, morning which time?
Boys, 8 o'clock, 8:30, 8 o'clock around 8 to 9. Otherwise, leave it. Otherwise, I'll come maybe tomorrow and day after tomorrow. Then we'll continue. Okay. Tell me what is IB? Now write the equation. Minus 10 plus IB R Thevenin is 6.66 kilo ohm. Okay, equation directly I'm writing here. Minus V Thevenin plus 1.4 volt VB1, this one plus IE2 equals to beta plus 1, that is beta is 100. 101 into 101 into IB1 equals to 0. So IB1 will be how much? 10 minus 1.4. Okay, into 6.6 kilo ohm, 6.66 kilo ohm plus, here it is 60 ohm also, 60 ohm plus 101 into 60. This is 10.9, 8.6. 8.6, and tell me, solve this one and tell me what is the value of IB when it's coming. It should come around 14 point. At the calculation. So this is 100, 100, 100. 10 raised to power 4, 10 raised to power 5. 6 into 10 raised to power 5. And this is around 6 upon 10 raised to power 5. and it's 8.4.
So is it 14.1 microampere?
It's around 14 only. So 14.1 microampere. This is IB1. Now you want IE1. IE1 will be beta 1 plus 1 into IB1. That is 101 into 14.1 microampere. And if you want IE2, IE2 will be beta plus 1 into beta 2 plus 1 into 14.1 microampere. You can solve the calculations and you can find the values. Okay, so I'll stop here. We'll continue tomorrow. Thank you. So once we do this one, basics, how to solve a circuit transistor, and then we'll do some miscellaneous problems. Okay, which came in miscellaneous means problems which generally comes in the exams. Okay, there will be some smart problems. We'll solve those. Okay, thank you.
Thank you, sir.